Hello, everyone. Welcome back to RoboCon and to the day 0 of RoboCon 2025, our awesome tutorial day. We had already a tutorial about templates in Robot Framework. We had a tutorial about Pabot, and now we will have a tutorial about remote library interface and how to integrate C# and .NET to Robot Framework. And I welcome here Nikolaus Rieder. And Nikolaus, I can hear you already.
Yeah.
You may want to pick a different camera if possible.
Sadly, that's the only one. I will try to get it working. It worked just a minute ago. Now it's not letting
And
me.
you are so handsome, and now we can't see you.
Yeah.
What unfortunate.
That is the switching of the browser. Suddenly it doesn't work
So
anymore.
we just before, as I mean, like the testers know that stuff. So we just tried out some technique, and it was hiccups, and it's also last minute. So we make a last minute release here now. So Nicolas just switched to Chrome. Typically, Chrome works better than Firefox. Let's see. I think we can also work with audio only as long as the screen sharing and so on works. So Nicolas, can you hear me still? Can we hear you still? At the moment, not. Good. But then I will just continue a little bit about RobotCon. So RobotCon is our annual Robot Framework conference. You can still buy tickets on RobotCon.io. The actual RobotCon day 1 will start tomorrow with nice talks with our awesome host, Joe Colantonio. You can, as said, still buy tickets to RobotCon, see all the talks that happened in Helsinki, see all the talks, all new talks that will happen tomorrow and the day after. And have also access to all our materials. So I, as said, briefly had Nikolaus here. You can chat and interact with us. I see him back here. I will just add him to stage again. Nikolaus, can you say something?
I can. I think audio is working. I will, for now, give up with the camera.
Yeah, that's fine. I maybe I find a picture of you somewhere, or you see a picture maybe in the title of the screen, so you can imagine how Nicholas looks like.
There's a LinkedIn link in my PowerPoint, so
Okay, that's good.
that might help. So I'm sorry it doesn't work. It worked a minute ago, and don't know what happened in the
Yeah, maybe
5
Nicholas,
seconds.
we just start with a short introduction of you. So one thing I want to mention for the people. So if you want to ask us any questions, specifically Nicholas, you can use the StreamYard chat here. Please just start with a Q column and then your question that I can mark that question for later. We will have first a theoretical round in the beginning, and then we will have a practical part. And after this first theoretical round, we will have all the questions. So please be a little bit patient. You can also ask questions on YouTube. We can also use the YouTube chat and blend them in here and ask Nicholas. And we will have a practical part later. And I can already pull up Nicholas' screen sharing on stage. That looks good. And I would say at that point, Nicholas, just a few words about you. So who are you and why Robot Framework? Nicholas, you're muted now. You have to unmute yourself again.
Okay.
Oh, yeah.
Can you hear me?
Yes.
Cool. So sorry for the video not working. I'm Nicholas Rieder. I am working currently as a test automation lead. It started just this week, actually. That's funny. But before that, I was a test automation engineer for distributed embedded systems. And I've been developing this remote library interface in C# for .NET Framework 4.8 for the last 2 years. And I've decided to port it into .NET Core in my free time. And this is the results today that we have now.
So you basically started for your former company, or so you switched jobs, or?
Yeah, I switched last Friday. That's the crazy part. That
Good luck in the
we
new job.
yeah we all left on good terms. It's just for me, it's a transition to some new experiences,
Okay.
and yeah, today is the finalization of what I've done the last 2 years. So I
Okay.
would say it's a good tribute.
Yeah. So and your former company had the need of having C# based stuff and C# based APIs, if I remember correctly, right? And
Exactly.
you were
So
searching for an alternative for an already implemented C# based test automation self-made thing.
yeah, totally. So we had a self-made test management system, which was not that good, and we searched for a test framework, and we stumbled upon Robot framework quite early in this searching process. The only hiccup was, oh, it's Python. And some little search later, I stumbled into an robot server, and I've decided to port it, upgrade it at least,
Hmm.
so we can work with it, because we had very many lines of code in C# for test automation already, and we really needed to get that going forward.
Okay. Um, and for those of you who want to get in touch with Nikolaus in Slack, your Slack name is hackxlt, right? Or is it
Uh,
IT?
it's IT.
Okay.
I have it. I wanna.
Bloody lowercase and
I have
so
it written under my name if they really would be
it's
working.
yeah, it's uppercase I, right?
Yeah,
So
uppercase.
and anyways, you will find it. The thing is, your name is not visible here because your camera is not working. Therefore, I just
Ah,
added it here to to the screen. So yeah, technical
that's
always
fine.
these issues. So you can find it, find him somewhere. That he has a skull as a symbol. So find him in Slack if you have any questions there as well. Otherwise, post your questions here. Um, uh, Greetings to Lydia, who is still watching us in the middle of the night from Australia. Hi, Lydia. She was really interested in this C# thing. So let's get the stuff going. Nikolaus, your stage is yours. So amaze us with awesome content.
All right, so um, I'm gonna go ahead and speed this up a little bit, because this is part of the introduction. We basically chose Robot Framework for a few reasons, one of which it is open source, it was widely used, it has the great Robot Framework foundation behind it, and it's obviously
Woohoo.
human friendly, so usability was a really core thing that we were going for, because the old test management system was not that great in usability. It is keyword-driven robotic process automation, something we had to adjust to ourselves. And most importantly, and this is the main topic of today's talk, it is highly extensible. And I mean that really greatly, because the extensibility of Robot Framework really made it shine for us. We were able to expand many things internally and you really use it to its course. So let's talk a little bit about .NET Core. Why would you even want to combine those two things? If you're dealing with .NET applications and web services or whatever, have you ever wondered if you maybe can test your C# code natively with Robot Framework? Or have you wondered that maybe I can confirm the actions I do on the web front end with the database backend? Or maybe you've wondered, okay, I just want to use all these .NET ecosystems that exist for test automation, but I still want to use Robot Framework. And here comes RobotCore to the rescue. It is a remote library interface written for C#. It targets .NET Core. Basically, it really tries to shine a light for this community. And it is based on nRobot server. which is originally written by Clayton Neal, but it hasn't been updated since 8 years or so, which is why I've decided to update it and make it portable to .NET Core. So first off, why did I even create this? I really wanted to enjoy the pain of distributed systems. And to do that, we really needed something that works with C# because we had a large repository of test automation libraries already written in C#, and we did not want to port that to another language. Also, I wanted to give back to open source, which is why I've really worked hard to migrate this to .NET Core, because we have gotten so much things from Robot Framework. I've decided it's time to give something back. And obviously, I have many testing use cases for C# environments that I also wanted to achieve with this. And for me, for myself, personally, it was a great contribution opportunity to contribute to Robot Framework. So to start off, I want to give you a really round introduction to what a remote library interface is. On the left, you see here the graphic that you will see in the user guide, which very roughly explains what it does. You have test data written in Robot Framework. You're calling some remote library. Then there's some protocol in the middle and another server somewhere, which is actually hosting the library and communicating with the system under test. So there's some magic behind of that, but basically said it's an API interface that you have to write for the remote server. And once your remote server supports these keywords in form of remote procedure calls, you have a remote library interface. The most magic happens behind the run keyword procedure call, and there's also all these other documentation keywords, actually methods that will give you more information about a keyword inside of Robot Framework. And since version 4.0, this is all combined into the get library information call. And additionally, you can also stop the server from Robot Framework if it supports stop remote server. So yeah, that's a basic introduction, but today we want to go a little bit deeper to really give you an idea about XML RPC, the protocol behind all of this. Simply said, because once you've understood XML RPC, you will understand how all of the remote library interfaces work, and maybe you can make your own contributions. So XML RPC is a really old protocol from the 90s. 1998, it was first specified. And it is obviously not secure because it is based on HTTP, but in a test environment, that might not be that most important part. And it is based on the combination of HTTP and XML data. On the right, you see a little specification graph. You get data from the left, it gets formatted into XML, transmitted over HTTP, then XML comes out again on the server side, and the server then parses that into code and gets the data. Great. So this is basically what a distributed systems architecture can look like. You have two servers or two systems talking to each other, where one system wants to make a call into another system. So yeah, XML RPC interface. What really is behind all of that? So it is data written in XML format, and on the right you see here like HTTP header that comes along with it. You can see it's a content type text XML. This is what gets transmitted on the protocol side. If we go a little bit deeper, we can see, okay, what gets actually transmitted on the interface. It's quite a limited structure. So you have the method name run keyword, as I've explained. And along with that, there's a parameter that tells the system, okay, I want to execute multiple parameters mixed. This is what my keyword is called. And I give all the arguments along with it. And if you're curious enough, you can see, okay, we have really basic data types inside of this XML here. This is what I mean by limited structure, limited data structures. And RobotCore does not implement this behavior itself. It uses an open source library called Horizon XML RPC, which is basically a .NET Core variant of the XML RPC protocol. And also here's the link to the specification if you're even more curious about it. So yeah, basically said, are those just keywords wrapped in XML? And I want to say it's not that easy. There's a lot going on behind the scenes. And first and foremost, it's just an intermediate machine data format. XML is what I mean. And for this to really work, we need to perform conversion on the client side as well as on the server side. Maybe you've heard about the automatic conversion systems that Robot Framework already provides. Well, if you implement the remote library interface, you will need to implement your own conversion for this to work properly. Because obviously you're in different programming language. So yeah, you need to convert into your distributed system, whatever language you've chosen. And this is a really painful part because making systems that are not really in the same programming space talk to each other can be a bit painful. I want to go even deeper at this point and really look at this XML RPC interface to get the gist of it. We have primitive types in Python and C#. For example, we have an integer that is also an integer in C#. We have a float that might be a double or a float in C#. We have booleans. Those are all basically the same. The only special one in Python is none, which is parsed into a string when you transmit it. If we go a little bit deeper, we have list types, which are represented in Python as this list with brackets. And in C# is a generic type where you can insert whatever primitive type you have in this list. And we also have dictionaries, which is also kind of special for the interface because you transmit a dictionary, but you're restricted to always use strings as keys. It's not, for example, possible to use integers as keys. So yeah, let's talk about this type conversion because I really want to make this point clear. Type conversion is the most essential part of any remote library interface for it to work properly and be a really have a high usability in terms of for the test library and test class developers. So yeah, there are language constraints that you must consider, and they will definitely apply here in our case with C#. And not all types in XML RPC might be supported in your language. So for example, in Python, we have a dynamically typed system. You can convert types all around. And in C#, we have a strongly typed system. You have to perform casts very explicitly. And they might not even work. There's also logging considerations you need to take care of and other some necessary communication parts that you need to consider. So for example, to log to Robot Framework, you need to specify this format. So Robot Framework knows, okay, yeah, we have a debug message, we have an info message, and you need to provide a Unix epoch timestamp with it. Then there comes the name of the logger and the message. There's also a specific port we should be using. It's a standard port registered by Robot Framework. It's ASCII for RF, very fancy. And it also requires HTTP post. That's a restriction that comes from XML RPC. All right, so we've got the basics. We have seen all these things. We need type conversion. We need a specific port. We need HTTP. We need XML. Let's execute some keywords. For Robot Framework, there's a bunch of data that you can provide. So Robot Framework knows how the execution went. So for example, you have a status, pass or fail. You also have outputs, like what I've said before, with the logging and especially formatted messages. We also have return types that need to be converted as well. We have errors, exceptions that get thrown, or simply just error messages being sent back. We have tracebacks. Maybe you want to provide your developer with the code lines where this error happened. And we have some special failure states like continuable, so you can continue execution if the keyword supports this keyword failure. There's also obviously the fatal failure, which will terminate the execution at that point. So yeah, at this point, you probably think, man, you've talked so much. This is all damn complicated, right? Well, let me introduce you to the wonders of being in 2025. This is very applicable for test-driven development because you have a specification. You definitely know all the types that you need to convert to, and you can write test cases for all of those things and write those test cases beforehand and then have a really easy time developing it. So it is a very testable feature in itself to have this conversion because you specify all the types that you want to convert to and write your test cases and then develop your remote library server along with it. There's also very remarkable features. For example, XML already has probably in most languages some proxy interface that you can just call, and you use unit test frameworks to mock your keyword calls like run keyword and get keyword information. And also, there exist a bunch of remote library interfaces already, so you can look at work from other people that have implemented the remote library interface in their language, like Java, in our case C#, and also Python. So yeah, it might seem complicated at first, but if you get the basics that I've just shown you and look at some other implementations, you might be able to implement your own remote library interface. So now I really want to show you what I've done. I've built RobotCore, sorry. I've built RobotCore as a hosting service for the purpose of integrating it nicely with ASP.NET and also make it modular in the implementation itself. So this is, for example, how you would host it. You specify all the services, the remote library, the HTTP service that you require, the XML RPC request handler, and so on and so on. Once you've configured that, which is all these lines of code, you can go ahead and load your libraries. You can use the service architecture I've described before to just get the singleton out, which hosts the keyword manager, and then just add your library in the form of a class. And you're not even bound to do this at the initialization stage. You can do this whenever you would like to, because the HTTP server doesn't really care, since the keywords are loaded once the client requests them. So you don't have to preload them in the initialization. You could also load them whenever you feel like it, as long as you have access to the service. And this obviously also works with assemblies. So you can specify a DLL and the full type name to the class that you want to initialize. Once you've done that, you will get to the point of discovering your keywords in your class. On the right, you see here a public class. It's called My Library. And it just to show you, okay, only public methods will get discovered. So you have the public method discoverable, which will get picked up by RobotCore, and the private method is just ignored. Additionally, what is currently not supported yet is method overloading, something I'm really working on, but might come in the future. But currently, if you do method overloading in your class, both methods will just not get discovered. And there's static and non-static support. So it doesn't really matter for RobotCore if your method is static or not static. It will just use it whatever. And also, you can make your discovery explicit. So maybe you don't want to expose all public methods in your class. You can use the robot library attribute and set explicit discovery to true. And then really have to specify each and every method that you want to expose in the service. So yeah, there's these primitive types which are currently supported in RobotCore. We have strings, integers, doubles, and so on. These are all the basic primitive types that Robot Framework also supports. We also have additional types, which might be really fancy because now you can define methods using the standard generic list in your C# class, and it will automatically get converted into a dictionary or a list in Robot Framework. So yeah, same is true for dictionaries. And there's also nested types, so you can nest a list with a dictionary and a dictionary with a list. The only restriction here is that dictionaries need to have strings as keys. So yeah, you've written your library, now you want to document it. And in RobotCore, there's many ways to document your library. What you see here is a method that is currently not documented, but what you could do is just write your regular documentation in XML. This is the typical way how you document C# code. And RobotCore will pick this up, read in the assembly docs, and display this as the documentation for that keyword. Maybe you don't want that, you want it to have to be more simple. Then you can just use attributes. So for example, you can use the attribute robot tags to supply additional tags to the keyword, but you can also use robot documentation attributes for just saying this keyword does this and that in one single string. You can also combine the two with the robot keyword attribute, where you can supply the documentation and also the tags in just one go. And also, you can document the library itself. You can write the robot library above the class and supply the documentation string that is displayed with libdoc when you get the HTML export, and also the initialization string, how you want your library to be called by the client. So yeah, that is basically the feature set that is currently implemented in RobotCore, but nothing in this world is really perfect or without flaws, and this is still a project that is in development. So it was developed from the predecessor nRobot server that comes with a few quirks that I had to deal with and I'm still dealing with. It was originally adopted for .NET Framework 4.8, and what I've done in my free time is port it to .NET Core that came with a lot of problems as well. So what you've just seen and all those features I've just explained are still the first alpha release 0.0.1. And I've set this version string because I wanted to really reset the versioning with the .NET Core migration. Even though I have been working on this for the last 2 years, but the .NET Core migration is really new, so I set a new version for this. And also, it is still being developed. It's a passion project of mine and also a project that I really like because I develop in C# mainly and something I can use to leverage Robot Framework continuously. So yeah, it's a work in progress, and I want to show you a little bit of a few things that I'm currently working on. So I want to improve the integration of ASP.NET hosting. Currently, that might work, but it might not work for every ASP.NET implementation. Maybe you have some security restrictions that will not allow HTTP, for example, and I really want to smooth this out. Also, I want to add the stop remote server keyword so you can call Robot Framework and say, okay, I just want to stop my server. I want to implement one important feature for myself, which is assembly swapping during runtime. I want the client to be able to upload new assemblies and switch out the old ones for a newer version without shutting down the server, which is really helpful in CI/CD deployments of continuous integrations or with test pipelines. And I also want to target whole RobotCore for .NET Standard to really make it the true shining thing, because then it will also be compatible with .NET Framework. all of this really comes down to a lot of documentation that I still need to write, an improvement to the README, and even more examples, so you really get to know how it works. And also, I'm currently admitting it's really missing quite a bit of CI/CD. For example, I don't have the Nugget packages on GitHub yet, and I also need to improve the currently really all the edge cases are flattened out. But that might have been a downside of this project. I want to look into the future with some bright eyes and welcome you all to contribute to this project. It is open source after all, and I've created this myself because it is open source. I want you to create issues and bug reports and just give me feedback on how this works out for you so I can iron out all the issues that you might have. I also invite you to make pull requests to make RobotCore even better for your use cases and for everyone's use case. And you can definitely reach me on Slack of Robot Framework to give me feedback on your experience, maybe things are not working for you. I will definitely be happy to help you out. So at this point, we have gone through all the theoretical stuff. We got this out of the window. I really want to give you a little break now because I've talked a lot of theory and shown you things around. And there will be a little break now, and you will have a chance to look at the repository of RobotCore. This is the link to it. I have some sad news at this point as well. What my original intention was to provide you with code spaces in GitHub, so you can just open it in Visual Studio and code in your browser. But for some unknown reason, the last 3 days, I couldn't get those virtual machines to work properly. So you will have to clone the repository, start Visual Studio Code, and attempt to use the dev container locally. And that is just a restriction I have right now. If you want to follow along what I will be showing you after the break in practice.
Okay. Thank you, Nicolas. Just one short correction. Let's go first into a Q&A session because we have some questions queued up here. We also have Lydia here that I will just now pull into stage. Hello, Lydia, and she also has a question, and she already yesterday said, "Hey, I will be interested in the C# stuff."
I'm really happy you made it after that time that is on your side.
Wait, what is it, like 12:30 or what?
Yeah, yep. It is just barely into the morning, so
oh my,
still doing all right.
So Lydia, go on. You had your first questions about the
my
typing,
first
I think.
question when you were going through the XML data format is whether you can describe any limitations you found where it was challenging to be able to test what you wanted to test based on kind of the requirements of the data conversion and the XML data format.
Well, for myself, I have really worked hard to iron out those issues specifically because I really wanted to use generic lists and generic dictionaries, really useful tool. For me, the biggest hurdle currently still is HTTP, not the XML part. The XML part works very well, but in many company environments, having an HTTP service running locally, exposing remote procedure calls is not the greatest thing. And you need to make sure that it is not exposed anywhere. And then you also need to make sure that you're not deploying this anywhere to production, because then you will give raw data to everyone else. So this is a really pain point for me. My thoughts on this have been long going. I have been personally thinking very hard about writing something for gRPC, which will basically enable the same remote library interface just on a different protocol. But that is a totally different story and also quite the endeavor, I have to say.
All right. Well,
maybe one comment before to your first question, like passing data through the XML. I think in general, everything that is pickable would work. So everything that can have a string representation would work, right, Nicolas?
Yeah, basically, yeah. So Robot Framework already does a really great job, and shout out to Pekka for implementing it on our automatic argument conversion. So in Robot Framework, you already have all of these conversions. You can represent integers and the dates and whatnot, just the strings, and it will automatically convert this. And for the remote library interface, it also works. It's just that the protocol itself does not support that many times. So for example, what I just said, the date time is something you can't transmit. You will have to format it
You
into
have to
some
make it
other
in
format.
ISO format or something
Yeah.
like this, right? Yeah.
Things like that, they might be in the specification, but they're currently not in the pipeline of just working. There's no date type that you can just transmit.
So there's some creativity in terms of how you translate the data you really need into something that can be passed through occasionally.
What we've, for example, done to circumvent some of that is either you write some kind of wrapper on the C# side, or you write a wrapper in the robot framework syntax, which will pre-format the data how you want it, and then either give it back or provide it, whatever direction you're going. But this is what we've done. For example, we've written a user keyword library, which already does all of this stuff, and we'll call the remote library interface with the correct arguments. And it's basically easy from there, but it's just a little extra step if you want specific types to be transmitted.
Great.
Yeah. One question that came up to my mind, and I'm actually not sure about that because I'm really rarely using the remote library. Is there already a possibility to have authentication in place? And is there an encrypted communication, or is it all just plain text, not authenticated?
Plain text, HTTP, XMRPC is so old that there's no thought at all. It has been promoted as the most simple way to implement remote procedure calls.
You
and
can do it everywhere, but it's open.
It is open like hell. I can show you in the practice later. If I make a call, I can just open Wireshark and I can see everything. So for example, if you would ever transmit a password, it's just there. If you ever transmit something that is anything security related, it's just there. So that's a really hard restriction. You really need to make sure that this service is not exposed. But you might be able to wrap it into a proxy that does some terminal ending, but it's still for an IT company, it might be still a security issue because somewhere there's still an HTTP service.
Yeah, for example, like in browser library, we also use gRPC to communicate between the Python part and the Node.js part. And maybe another thing that could be nice for the future to actually implement a specific dynamic library part on the Python side that does all the C# specific type conversion, where you can also make custom type converters for your C# types, for example, dictionaries with integers and all that stuff, and then have kind of the interface between this very slick Python part and then your rich C# part, maybe over a proper API, to kind of have a plug-in replacement for the future. That could be an idea.
I personally think going the route of gRPC is the way to go. Simply said, because it's a remote procedure call protocol, and you can write your own protocol for everyone, and then just generate your clients and server code from that. And then you're really off to go, because gRPC allows for, okay, I want a C#, I want Python, I want JavaScript. It's just there. The only hard part is specifying the protocol itself. I've been there.
Okay. There is one question also from Daniel here. One part we had already discussed, like why gRPC, why not something fancy? The other thing is, have you thought about Python.NET or .NET Core?
We definitely did tried that out. Python.NET is actually really great until the point where it breaks, because you need dependency loading and you need to package so many things just into Python, and having the whole dependency chain with an extra step is really just a hassle. For us, it was really like we have 100,000 lines of code, dozens of packages, and just putting that into PythonNet would have just been so much trouble in CI/CD.
Mhm.
And that's why we didn't use that road, but we did try. And for the other thing, yeah, we
We
did not
already
decide
discussed
to
that, yeah.
use XML RPC. We just had to.
Sure. Yeah, Pekka had the same question, so Pekka is also listening.
Oh,
And the other thing that Pekka also said, hey, please make a pull request to remote interface project to get this remote server listed. So at the moment, we of course have the nrobot remote there listed. It's just to get your stuff also listed, so that other people that are searching for don't have to use nrobot remote, but they can use then the new Python net core.
I will
So the
definitely work
RobotCore.
towards that. It's definitely a goal of mine. Currently, I'm trying to iron out the CI/CD so the deployments work for all the users.
Okay. Then we have another question from Peter. Are there any specific templates or best practices for writing keywords in .NET Core instead of Python?
I would say the dynamic shifts a little bit. Once you're writing in C#, you're suddenly not restricted by the robot framework world that much. And I've personally used the best practice of developing an API for robot framework. So instead of writing your keyword library, so people can use your keywords as a library function, I've written it more like, okay, somebody's making a call to my interface and I will deal with the rest. So it's not like you write your really short functions, you actually write some more sophisticated stuff. For me, for example, we've written dozens of protocol analyzers that just do the analyzing behind the scenes, have background tasks running, and Robot Framework calls in to get information states or just write expectation keywords to check for the protocol itself.
Okay. Then we have another question. Does it support async or await in the current version? If not, is there a plan to support it?
That is a hard no right now. I would like to support async, but sadly, the asynchronous stuff in Robot Framework is something that I have not dived into much, because once you have async, you also need to use the asynchronous version of Robot Framework. And currently, I think the remote library interface that is implemented does not support this async stuff. So
Yeah,
you don't have the callability of async in the actual remote library implementation. Might be something that is easy to adapt. I think there are some pull requests that try to do it. I've seen them in the past, I think, at least parts of asynchronous robot framework library implementations. But currently, no, it's not supported.
I think there. So instead of having like this generic remote interface, having something more C# specific on the Python side, for example, as I said, custom type conversions and so on. And I think also async handling would be a possibility. What we already also do in browser library, we use thread pools to actually return a promise or return a future and then resolve that future later. So we can do this promise to download a file, and then you just get this promise from this thread, and the thread is actually executing that call over gRPC, and at some point it's done, and then we can resolve it afterwards. So you can do it already now, but in your own library, and I think that would be a nice feature as well, to also deal with all these specifics, maybe even with and that leads to the next question, the topic of return types. Maybe even if you want to return an object, or you gather an object somewhere on the C# side, and obviously that object maybe is not pickable, it's not streamable over strings, so you want to have that object somewhere in the memory on the C# side, but you just return a UID to that element in your memory, and later you can use it then again, so you turn back the UID, and it would be somehow transparent for the for the users of robot. So you could have kind of state handling in this C# library. So Peter asked, like, is there any limitation for returning values? And that would like to. Yeah.
Currently, basically only the supported types are allowed in the return values, which are all the types that you've seen before. But for example, what might be something that ties into what you said before is I'm currently missing the implementation to transmit binary. Because there's a possibility to transmit binary with XML RPC. I just haven't implemented that specific type yet, because in C# I really need to think carefully how I'm gonna serialize objects and things like that.
Yeah, I think there was, not sure, maybe slight hiccup in the types. So string is str, int, then we have float, double, right?
Yeah.
Yeah. So I think yeah, double, and then we have the Boolean, and the lists of all these types are also supported. Yeah. Okay.
Yeah.
Okay. Then great. Maybe I put back. Let me just see your slide here. So we will now have a 10-minute break, and after the break we will do some practical stuff. Correct?
Yes.
Nicholas?
I will show you basically how you can write this service that you require to just start the RobotCore service, and also how to implement some basics for a library class. I will, in that process, I want to show you how it's working, how it's running, and as I said, it's version 0.01, so some hiccups might be implied, but still, it is working very nicely with the conversions. And I will also show you some intricacies about the remote library side in terms of hosting.
Okay. Thank you, Lydia. Maybe you can also follow the practical demo, and if you have some questions, then Nicholas can maybe help you as well. If there's anyone else really want to follow and want to ask some live questions like Lydia did, just write in the chat of StreamYard. From YouTube, it doesn't work to pull you in, but if you're in StreamYard, if you have booked a ticket to RoboCon, then just type in join, and I will send you an invite. Then you have the possibility to join this live room here as well. And I will play out now a 10-minute timer. When the timer is gone, Nicholas will be here again for for the second part of this tutorial. And maybe, Nicholas, you try to figure out your camera if you are interested, or you just take the 10-minute break as well.
Definitely. Try to figure this out.
Fingers crossed to see Nicholas then live with camera after the break. Thank you very much, and bye-bye. See you soon. Okay. Hello together. Hello everyone. Nikolaus, are you also back here? So there you are. Can you say something?
Thank you for putting in a picture.
Yeah. So I just try to pull out a picture somewhere. So here also you see. Wait a second. I put that away. So for the German speaking audience, you can also search for the software testing podcast by Richie Seidel. There was also Nicolas who explained a little bit about his journey, and there you see also a picture of Nicolas. So that's how he looks like. Okay. Yeah, then I would say we can go on. Stage is yours again, right?
All right. Let me just switch to casting because I'm focused.
Okay, in the meantime, I can maybe give a shout out to our sponsors of RoboCon right now. So as you see here, we have these. Wait a second. No, I don't want to have this. I want to have this or this. Yeah. So as you see here, TeamScale, BQA, Imbus, which is the company I'm working for, Efficode, Vala, and Go4 are gold sponsors of this RoboCon. We also have Index 9, which is the platinum sponsor of our RoboCon Online this year. And we have all the silver sponsors at the bottom there. Those companies are just giving us some more extra money for making RoboCon possible. Thank you very much for this money. This really helps. Also think about maybe if you're using Robot Framework heavily to join the Robot Framework Foundation. Go to robotframework.org/foundation. You will learn about the Robot Framework Foundation there. If you think it's not possible to actually become a member of Robot Framework Foundation because your company is too big or you don't know who to ask, you can always also just buy more RoboCon tickets and don't come. RoboCon online tickets, for example. Then we wouldn't order food extra, or become a sponsor of the next RoboCon and just buy a sponsorship and support Robot Framework software development, Pekka Clark software development, or even ecosystems that are funded by the Robot Framework Association. So I will bring up your stuff again to stage and shut up for now. And stage is yours again.
All right. So I hope you will see a little bit more of the screen now because I've shared my desktop for the reason of me switching around with tabs in the next 2 seconds. So welcome back. I just want to mention René will allow you to put some questions forth. So if in this part, if you have any questions on what I'm doing, why I'm doing it, feel free to ask. You can interrupt me. This part is generally intended for having live interaction. So we will take about 45 minutes or so, and then we'll have another Q&A after that, where you can ask questions about the process that I'm showing you. As I've said before, I'm really sad that the dev containers part with the browser did not work properly, because then you would have had an really easy setup. Now with the cloning and possibly getting wrong states, it is much harder, because what I actually wanted to do is deploy an image so I know that it works on your machine. But that did not work out due to virtual machines in the cloud.
Can you just click on Ausblenden at the bottom?
Yes, thank you for the hint. So yeah, we will first start with a little bit of testing, because I bet you want to see more robot framework, let's C# for a moment at least. Yeah, we'll basically show you how to run RobotCore in the sense that you just start the service that already exists in the repository. Then I will show you, how you can actually, as a client, if you maybe don't know the keywords, discover some keywords that are running on the remote server. and also how to execute this remote library keywords by using the remote library in Robot Framework and execute some keywords there and some things that you might have to consider. And also, we're going to view what the documentation looks like if you're running it through libdoc. All right, so let's get to this part. I have for myself chosen Visual Studio Code because it's very common in the Robot Framework world. So what you see here is a little bit weird terminal interface, just for the reason that I have one terminal in the folder with the standalone server that is in a repository. I've also just committed a quick fix, which removed a typo. And if I want to run this, I simply run .NET Run. For this, I need to have the SDK 8.0 installed, or at least 8.0. And then this robot service should start. There are a few warnings. It's early version, but those are due to nullable types and can for now be ignored. And then you will pretty much see nothing. It's just a server that starts in the command line, and if you press any button in this terminal window, it will close itself. And on the other side,
can you
yes?
maybe increase a little bit? So like zoom in with Control Plus or Control, and yeah, that's already good. Yeah, perfect.
All right.
Thank you.
So basically, in the other terminal, I am in the RobotCore repository, and there's a subfolder called test with another subfolder called Robot Framework, where I have a bunch of directories containing Robot Framework test cases. I'm sorry, it's so I'm looking like this. It's Windows still on my side. And for this demo, I specifically have RoboCon demo, and it really just contains this demo file with a hello world keyword. All right, so we have on the left side, in my terminal at least, started the server, and on my right side, I will execute the test cases. But first, I want to really show you, okay, you can discover keywords if you, for example, have the extension robot code or the language server installed. It should be able to pick up the things that are necessary to run the get library information keywords, actually remote procedure calls on the server. And with that, for example, this keyword that I've written here is wrong. And I will say, okay, maybe here I get some information about what is actually running on the server. And what has actually happened in the background is that the extension, repeating again, it's called Robots Code by Daniel Biel, is calling get library information, which contains a gigantic dictionary with all the keywords that are loaded in the server, which currently are all the test keywords that I have installed. So you see a lot of different variants of keyword, how to call keywords with different types to test the conversions and stuff like that. And at this point, I really want to just use the simple example library I've written. Just going to show it to you here. This is the very simple example. It is a simple class with just public string, write string, and it just outputs that string. I will go into detail about it a little bit later because that will focus on C# more. Just wanted to show you the keyword. And here I will now, going back to here, use this keyword to write my string that I want to write. Hello RoboCon, and another keyword, another argument is 2025. Then we'll save it. And then just use robot in the command line, at least for this presentation. There's other ways to do it. We will execute the RoboCon demo, demo robot, which currently failed. Sad about that. That is the first time. I think I know why. Okay, I've added it here. Did not find the keyword. Did make a typo. It's called write string. Yeah, I did make a typo. It should be, if you want to have those robot framework style spaces in between the keywords, you need to put an underscore and it will automatically format it. So now I need to restart the server because it was a bit too quick. I'm sorry. All right, server's running again. Now we should get our keyword. Let me just check. Example, write string. Gonna use this again to see if the example is actually, I forget the most essential part. In C# you have to build your projects. It's not that easy. So yeah. All right. So now we should see a write string keyword. If I'm not totally wrong. Okay, might be wrong. Having a little trouble here, so I'm gonna redirect to one of these parameter types just to showcase that it has some keywords loaded. I might have an overlap I have overseen. So I'm just gonna run some string keyword type to showcase that it's working. Sorry for the stuff. Not found. Okay. I'm sorry. I had I should mention you need to set up your remote library, and I had the variable here that I forgot. Okay, let's try this again. Still nothing. Let's stop using this and start using something that we know of. Still nothing. Okay, again a variable. I'm just gonna make it a concrete type now because I'm a little stressed out that I have run it so many times. It did not work once yet. And there we go. It executed the remote server and tried to say hello. So it found the library. It just now we need to use our actual keyword that we wanted to run. And we did it. Okay, that was a long story short.
Don't worry, we can all cut it out, but we won't.
So now I really want to explain what I've done here. This was supposed to be a really quick demonstration. Took me a little while. I'm sorry. Typos. So what did I do here and what happened here in the background? For a remote library interface to work in Robot Framework, you might know or you might not know, you need to use the library keyword with the special name remote, not capitalized. And then you will need to provide an address. In our case, it's always HTTP. And let me just get rid of this comment here. I'm sorry, ChatGPT auto-completions are sometimes the worst. Can't disable them now. And you will need to specify your host. And I really want to quickly mention, it does not have to run locally. In theory, and also in my personal practice, I have made it available into a local network, and you can have different hosts as long as their firewall and everything else permits the standard port, and have them communicate with each other. Because it's a remote procedure call protocol, it does not have to run locally. it just is the case that usually you run it locally if you just want to execute C# keywords. But for my use case, and also specifically why we really needed that, is we have different servers with a multitude of C# network code running. And we want to call this server from multiple clients and have them all communicate with devices through our C# interface. So yeah, it does not have to be localhost. It could be any IP address or host name that your client can find. And then in the next thing, you obviously need the port. I really want to make it apparent. It does not necessarily have to be 8270. That's just the standard that it is specified in Robot Framework and what you should be using, because it's a standardized port and it's registered with IANA. But if you maybe don't want to use standard ports, you can also configure this port in the program on the RobotCore site. Then we will have the usual ending slash for the address. And then we will need to specify the class name of the library we want to call. So this is really essentially just naming the library. And in our case, it has to be the same name as the class that you want to call. I've previously had it in a way where you needed to specify the full class name, and you might be still want to do that due to possible collisions that you have in your C# libraries. But I personally found those really long names to be really annoying for the remote library initializations. So I opted for using just the class name.
Maybe one small comment. The with name, I think is, I'm not sure if it's actually deprecated, but you can also use as now.
Yeah, I did not intend to write that. I have sadly still ChatGPT completion activated.
All good, all good. just as a side comment. Go ahead.
I really want to deactivate it now, but so yeah, you can use the as keyword, and you should use it because then you don't get those deprecation warnings. And I really recommend, because previously we had this question about best practices, whenever you use a remote library, I really recommend to use the as keyword to really make it apparent in the specification of your test case that you're calling something else other than a local keyword. So not for the sake of just naming things and differentiating things, but for me personally, it's really a mark of, okay, this keyword needs some form of communication and might not run anywhere. So for me, that's really important. You can call this anything. So for example, you could call this remote lib or whatever. That's totally up to you. I just like to call it something that is recognizable. And with that, you will always have to you have to use this prefix to use the library, and then in your specifications, you really have a clear indicator. Okay, whatever I'm doing here in this keyword is actually calling remote procedure calls and is communicating over the network to perform this action.
Yeah, and you also you can also use more than one remote library at the same time, and then you definitely have to use this as anyway, because otherwise you would get library conflicts.
Yes, with one little thing. In RobotCore, there can only, at least for now, be one instance per class. That is due to potential
on one machine or what?
On one machine. Yeah, if you have
Okay.
multiple, then obviously it works just fine. But if you have one server, you can only run this once. On the second time, the server will say, I'm already having something running here. And so, for example, what I'm not able to do, if I copy paste this and put it here a second, this still works. This is still
okay. That's the same one. Yeah, this is the same port. Yeah. But with the second port, it wouldn't work, or?
With a second port, it would be fine. Yeah, if you
Okay.
just run another service and another port, that would be fine.
Okay.
But
Okay.
it's just that the service itself needs to instantiate this class, and to avoid multi-threading issues, at least
Yeah.
in the first development, I wanted to really lock this to a single class instantiation.
Okay, but if you would like to, I don't know what use case you would have, but for example, if you have 2 times your specific library running in a slightly different configuration, you can spin up 2 remote servers at the same machine. That would still work, because then they are under a different process, right? They are
Yeah.
separated from each other. That's fine.
That would
Yeah.
work just fine. You just need to specify different ports so they don't overlap, and that would work just fine. It's just the restriction of one server needs to really instantiate
Yeah.
each class.
Yeah. Okay.
But yeah,
That's good. Yeah.
so we have seen how to initialize this remote, and that's what I've tried to do with this remote library resource. The reason it didn't work is because for some reason those variables didn't get picked up.
Can
And
you briefly go back to the resource file?
Yeah, the resource file is
Oh yeah,
something.
but the init report. So the resource file does not, the resource library. Can you go to remote library resource? That one does not load the init robot as a resource file. Therefore, the variables of the init robot are only available during the initialization file, and they are not propagated to the children. So
Okay.
yeah, the init robot has only basically 2 local variables. They are not global. These are suite variable scopes. By the way, if you want to learn about suite variable scopes or variable scopes, you may want to look out, short commercial break, to our sponsors, because some of those sponsors are also accredited training providers for the Robot Framework Certified Professional. So for example, BQA, Imbus, and also others. And the Robot Library Scope is part of the syllabus, so stay tuned. Watch the opening tomorrow. You will learn more. Okay, Nicholas, go on.
Okay. So I really wanted to show something specific about what I've done for testing all of those my conversions. I have this extra library test repository in here. Just gonna open this up again. See it? It's called just tests library, I guess. And inside of this test library, there's a robot file called static type conversion. There's also another one called arguments. And I really wanted to just run this for once to showcase that a whole test suite, because it's a really big test suite, can run all through just with the same server. I already forgot the name. It's called test library. So tests library. And inside of there, there's the static type conversion. It's called static type conversion because I've explicitly written out all the type conversions to really make sure. And if I run this, it will perform a bunch of test cases, unless, and some of them still fail. This is my test-driven development that I'm still working out a little bit. But most of them should have passed, unless the library was not called. Yeah, and you still need to switch to the instance with the test library. Sorry for that. So it should be running now. Taking a minute there because I'm streaming in the background. And I wanted to show this while it is running here, because now you can see a little bit of debugging information on the server side. And also the reason why it's taking quite a long time is because it skipped the get library information, but yeah. And you can see the extension actually trying to call all the, get documentation, get arguments, get types. Currently, it shouldn't do that, but I think I had a little hiccup in the first try, so it skipped. Once it fails the first time with the get library information, it will just use the old school variant. And here you can see what the server actually does in the background. So it gets all these calls by robot framework to get all of this type information, get all the information to execute a keyword. So you as the user can have the automatic conversion working. And this is basically how the communication takes place between robot framework and the remote library interface server. It's taking quite a long time now. I'm not going to go through all of this simply because I'm streaming in the background.
Can it be that it tried to have this one call in the beginning when the server was actually not yet running?
Yeah, it definitely did, but it's I think it's also tremendously slow. My PC is not that slow normally. So I'm gonna stop this for a second. Make sure it's running now. I'm using my IDE, by the way, because of the debugging mode here. So yeah, and now it's running, and now we should see.
Oh yeah,
Yeah,
that
it's
was
starting
very
to execute, and if we look here, this is how it's normally should be doing it. It's just calling once get library information for all of the library information, which is much more performant than, as you've seen before, calling each individual keyword. And then now it's just executing those keywords, those test cases for my conversion. Some of them still fail due to formatting issues, but pretty much 90% of them are going through, which are mostly the types. Those bugs you see here are just because of in C# I have the wrong culture set. One server tries to format the float with a comma, the other one tries to do it with a dot. Yeah, that's just a culture thing. So, but actually it is working. And as you can see, I can perform a whole test suite on this server. It might seem a little slow now. It is simply because I'm streaming in the background to you. Normally this would already be done. And it's passing all of those test cases. And I really want to showcase this because if you're ever stuck or want to find out how I did this, you can always look into this repository and check out, all of the different ways you could call a remote library keyword and see what it should be doing. Like, for example, this is a keyword called integer32 parameter type. And it's called that way because inside of C# it is an integer 32. And it will do the conversion, and I will check if they're equal on the local side. And yeah, that's for the part of the demo of just giving a rundown with how to get the server running if you're just the client. It is really as easy as just running the executable that some developer in your company might provide you with if you're the test engineer. And that executable will have the server and the library is called. I will now show you some more about the actual documentation that you can get out of it. So if you're maybe unsure what kind of keywords the server has, let's go back to our example with the standalone server so that we don't get bloated with too many keywords. You can always use libdoc, great tool by the way, to also initialize a remote library interface. So you can use libdoc remote double points,
Column.
double colon, and then exactly the same address as before, 8 to 70, and I will now use the test keywords, which was the one with all the documentation. I will use the with documentation class because that's the one that showcases a few documentation styles. And then I need to provide a file name. Takes a little second.
Maybe the server's not running, or
yeah, maybe I need to use this one again. I'm using this one, so it's a little on the safer side because I'm not that familiar with the .NET Run interface, and here I have the correct executable with the libraries loaded. Let me just try this again. Yeah, now we have it. And I want to show you what this look. No, not this way. Just open it in the browser. I guess you've all seen what a robot framework documentation looks like. And since libdoc is so great, I did not actually write my own documentation exporter because it simply works for the remote interface. So yeah, you can call it for a remote library, just like any remote library, and it will provide you with all of this documentation. Here, this is just a really simple example to showcase various ways you could document a keyword. So for example, this documentation word is actually the actual documentation string. It could be way longer than this. It could also contain HTML if you want to, because libdoc will parse that anyways. And there's also initialization. So for importing the library, for example, you could specify here, oh, you have to use library remote and the address and whatever to your heart's desire. Then we have some keyword documentations. This one, for example, is a keyword that is using the triple slashes, which is the common way to document functions in C#. And you have all the parameters documented, and it is simply reading all of that information from the generated documentation file when you build an assembly, if you have configured it to do that. And this will go here. Then there's also the way of using the attribute. This will just provide whatever string you have in the attribute. In this case, it is parameter information returns void. Actually, that's a default string. I'm sorry. In this case, I don't think it worked. Then we also have tags. And I want to highlight that tags are really important to make your robot suits really shine. Because then you can combine different keywords, and basically you can use it for parsing, you can use it for post-processing, pre-processing. Tags are really a nice thing to get many things in CI/CD done inside of Robot Framework. So it's a really important feature for me, at least. And there you can also combine it with the robot keyword, and it will look like this. You will have tags and a documentation string. So yeah.
Do you get already the return type hint over the remote library API? So in the robot framework, I think 7.0, we had integrated not only arguments but also return type.
It should do that, but I think in this case it might not work because they're all void.
Okay,
and void is not
then there is no
parsed
return
back.
type. Yeah, sure.
Yeah. But I can show the other one. Let me just. Actually, I already did that. Just skip this step. And you can see here. Do I see some return type? Let me just scroll down a little bit. Don't think so. No, I don't think it works yet.
Okay. Maybe one other thing to shortcut this library documentation. If you just go to RobotCode and you go where you have your remote library imported. And
yeah, I know you have the RobotCode documentation as well.
Yeah, there you can just right click on the remote library line basically, and say I think source actions. Yeah, right click and then source actions and then show documentation. And I think on the library. Yeah, and then open documentation. And that you can also, there's on the right side. Wait a second, I will put you on site. There is this small square. Oh.
There's some issues there, I guess.
Getting keyword names from remote failed, calling dynamic.
Getting keywords from names from remote failed, calling dynamic. Don't know why.
Okay.
But finding bugs is my job. So
yeah.
I know. I see why it actually did not find the example library.
Because that server was not running under that name, right?
Yeah. We have to use the. I could just rewrite it now, but yeah, that's also a way how you could call it. If I would write test keywords here, it would work. So
source actions. Yeah. And
here. Yeah, I also know that. I also want to mention there's also the language server extension, which has this neat documentation part down here. You could also just use that one. I just like to use the command line a little bit to get the point across of how the sausage is made. You can definitely use all the extension tools that you have available.
One word about the language server. The language server is unfortunately not maintained anymore, and it does not support Robot Framework 7. So that is considered deprecated, and they also said they won't do any security patches after February this year. So that's basically out of date. But there is another extension. It's called DocsView. And DocsView just also adds the keyword documentation or so in kind of this I think DocsView, or was it there in the middle, is it? There was that one. If you click install, every time when you have something selected like a keyword or so, you will have also a doc like a small container there in the tree, or you can also put it on the side of the terminal and so on. So every time you have the cursor on something, you will see the doc string of that thing there. That's also very, very helpful. And it can directly also be used with RobotCore together.
It's a really good note. I will remember that. Thanks for teaching me. So yeah, what we've seen now is all that I wanted to show you for the testing phase, because I'm personally guessing Robot Framework. I don't have to show you all the various things you could use it. At this point, it is just calling keywords. So all the different things apply. The only thing that you always have to consider is the types, but those are all already tied to whatever the keyword is asking for. So if you supply, for example, a wrong type, the remote server will say, hey, I expected the argument to be this type, just like Robot Framework would do as well. So yeah, at this point, Robot Framework, I think we're done. You can definitely figure this stuff out yourself. The user guide is very comprehensive. I'm gonna go now more into depth with the C# part. So at this point, if you're not familiar with C#, many of those things might not be easy to read for you, but it's something I really wanted to show, because this is also a test library interface, and you would have to write test libraries in C# for this to work. So what I wanted to show you is how this hosting service is created, because the way RobotCore is written, you don't have to use my repository standalone server project that I have there. You could just write the essential hosting service part yourself and put it wherever you desire. I also want to show you how to add the robot remote library, meaning how do you add your own classes to this service that you've just launched. And we're going to create a little library class, basically the right string we have just used before, and extend it a little bit just to showcase the various ways you could write a library. And then we'll add the library class. and we'll start RobotCore and basically execute Robot Framework again, hopefully with less hiccups. I think I have ironed out all the difficulties now. And we'll go straight into it unless there are quick questions in between those two phases. So if there are ones, it would be a good time. Sorry, did not want to spam. I guess they are not.
No, so at the moment we don't have any questions, but bring your questions in. So to the audience, if you have any questions, bring them in.
In the meantime, I will open. I will open personally JetBrains for me because it has a nice syntax highlighting for what I'm going to show you now. But obviously, you could also just use Visual Studio Code. I just want to highlight the host service with Visual Studio with my JetBrains IDE. I'm gonna make this a little bit bigger so you can actually see. And we're gonna go through this step by step. So the essential part you need to run RobotCore is some kind of logger. The logger might not be necessary for the communication part, but if you want to show anything to your users, you will need to configure some sort of logger. RobotCore is written with the Microsoft extensions, so you could basically import any logger that supports the Microsoft extensions logging library. So in my case, I like to use nlog, and in the in the RobotCore repository, there's also a default implementation you can look at. It's called RobotLogger, which I just initialize here and use the configuration it provides to provide it to the host service. So yeah, this part, if you're unfamiliar with it, I'm sorry. This is basic C# hosting. It is using the Microsoft hosting extensions also to make it very approachable for various types. And we're creating a builder, and we first configure our logging. In our case, we're adding nlog. We're setting the minimum level to trace, and that is for a specific reason, because the way we record any logging that is happening during the execution of a keyword, we are using one level above debug because there's a reflection mechanism that allows us to basically collect everything that has been put into trace for that period of time. And that's where we have to use the minimum level of trace for this logging. It also only has to be configured for this specific logger that you're using for the remote library interface. It does not have to be configured anywhere else. It's just for this one that is executing the keywords, you have to use trace because we're collecting debugging information of the actual executed keyword. Next step, I'm just adding nlog. I'm using the previously initialized robot logger, which has a nice property to just provide the configuration for us. I'm just going to quickly show what that looks like because it's not that complicated. Because we have one Unix epoch layered renderer, and we have one generic logger name layered renderer, and those two combined are using a specific layer, the one that I've shown you in the slides, which is those asterisks, then the log level, just written in a C#, in an nlog style, then the Unix epoch logger, a name for the logger, and then the message, and potentially with the exception or without the exception, whatever you like. And then we configure the trace target to use the trace level up to fatal. Yeah, that's basically it. One small thing, if you're using nlog specifically, and you do this configuration yourself, you have to use raw write in the trace target. That is due to a bug that exists in nlog, that it wouldn't output any information if the raw write was not set. I will, in the future, hopefully iron this out. And it also is very specific to nlog in this case. Yeah, once you have your logger set up, that means you're now able to execute keywords, and the information that those keywords are putting into the trace.write line are actually being transported back to Robot Framework. So there's a distinction to be made. You're not using console.writeLine, you're using trace.writeLine. What that looks like, I can quickly show you here in the standalone server and example library. Here I'm using trace.writeLine, not console.writeLine, and it using to use the system diagnostics. So yeah, in the next part, once the logging is done, you have to configure the services. And there are a few services that RobotCore requires. The most essential one is the Robot Remote Library. I might rename this into the future to avoid confusions. This is actually the remote library interface remote library. So it is hosting all the keywords like run keyword and get keyword arguments and stuff like that. This is why I've called it remote library. And this singleton, the single instance of this library, also hosts all the other services that you require, and you get those by just asking for the interface. For example, to get the request handler for XML RPC, you ask for the interface XML RPC request handler, and to get the Robot Framework Remote API, meaning the run keyword, get keyword arguments, and so on, you use this interface. And in both cases, we are simply just retrieving the already initialized Robot Remote Library service. Then an extra step is to initialize an HTTP service. This HTTP service is also already supplied in the XML RPC service, but it is an extra step because possibly you might want to write your own HTTP service, which is internally just calling the XML RPC request handler. I'm not going to go into depth in that regard unless you're asking me to. But this is specifically done in that way because you probably want to write your own HTTP service, how the different signals are handled, like how do you want to handle the post, the get, and you might have your own web page, who knows what. So that's why this is externalized and not included in the Robot Remote Library. And then last but not least, you need to add the iKeyword Manager, and this is the main central instance that will host or actually instantiate the classes that are then served as libraries to the user. So yeah, you just use iKeyword Manager as the interface and then Keyword Manager as the class to add the singleton. And it all should be singletons because at least in the current implementation, I'm not supporting multiple instances of this service. Then you just add the .build and the host service should compile for you, and it will also call all the necessary constructors. If you have any issues at this step, you might have misconfigured one of the services because in the way C# works, it will initialize the constructors with all the necessary interfaces that it has registered. So yeah, at this point, everything should work. And now we're in the user code, or actually the actual host code that you might want to do in various ways. I have added it here directly below the build, but this in theory can be done anywhere in your application. So what the single thing you need is to get the required service iKeyword Manager, and with that manager, you can add libraries. You can add libraries either via instantiating just a class. You can provide a type information, meaning type of example library in this case. This will also instantiate this class, but just using the reflection type information. And lastly, you could supply example library.dll and then the name. Actually, it's called differently. It's called, in this specific case, RobotCore.standalone server.dll, and then the same one again, just with example library attached to it, which is the class name. In this case, we do need to use the full name, simply because this is how C# needs to, that's all the information that C# needs to instantiate the class. And once that's done, that is basically it. So there's no, after you've added the library, it is available. And the next time someone asks the server for this specific class, it will provide the same get library information keywords. If anything goes wrong at this step, it will already fail at the add library part, like telling you, okay, I can't add this library because possibly it has some, I couldn't find the assembly, I couldn't instantiate the class, whatever. There might be some issues here, not on the RobotCore part, but maybe if your class has some implementation issues. At least when you're loading it as assembly, it's not that guaranteed. But yeah, that's basically it. You're adding the library here, and the rest of this code is simply just to allow the service to run in the background. But this part is not that important. So everything that you do need to run RobotCore is to configure logging, to configure the services, specifically the robot remote library, and then to use the iKeyword manager to add your libraries during runtime whenever you want to, or during the initialization of your class. Good. Having this part out of the way, are there any questions so far? I know this was very technical, but
no, at the moment we have no questions. Or Lydia, do you have one?
Yeah, I'm happy to jump in with my question
That's
again,
good.
because it is kind of, with the two pieces you've gone through, one of the things I'm curious about is any recommendations for managing development environments and sort of repositories in terms of having the C# and Robot Framework Python duality, and if there's anything you've found to be helpful in terms of helping both the test engineers and the developers find things, manage things, understand what's what, and how to use it.
I have to say I'm not employed at my previous workplace anymore, but I can tell you how we've done it there. Yep. And it was very specifically disconnected from each other. So we had repositories that were set up with Python poetry specifically for Robot Framework. And those were simply for the user keyword libraries or the test cases and all this stuff. And what we have done in the development part is we have written a Python user keyword library that makes the actual remote library easy to use. So the remote library provides very generic functionality. So it is not actually single methods that do one very particular thing. It is actually very complicated methods that do analysis in various parts. And with the user keyword library on wrapping around the remote library, we are doing very specific things with that, like placing one expectation here into the server, or asking the server to perform one specific action. But the library itself in C# is kept separate. And we also exclusively use Nugget as the package manager. And there's some ease of use there, because you will have some part in your application that actually does the service part. And you will have another part that is just a basic class library, like any class library. Basically, it could be a project that simply just contains this class. And it would be important for you to separate those things, because what I've done here, for example, putting the standalone server together with the library, might seem like the easy way, but it's actually way easier to manage if you have multiple projects that are just supplying their Nugget package with the classes as a class library. And then whenever you need to use it, you just consume those packages and initialize whatever classes are inside of there. On the robot side of things, the documentation already handles the part of, okay, how do you use it? Because you can, for example, in this example library, as a developer, you can always tell the user, okay, this keyword does write a string to the console, the text to write, the year to use for the message, and it returns the written message, for example. This is how I would do it. You can document all your public keywords this way. And when you do this very extensively, you will have a robot framework side of things that simply uses the HTML documentation to know how it's working, like any robot library. And on the C# side of things, you're keeping things very tied down to Nugget packages that you deploy in various ways. Because again, having just simple class libraries that are separated from the service and the hosting part really makes it easy also to maybe test your own libraries if you want to do that, if they're really complicated, they need their own unit testing maybe, and who knows. Or what we've also done is if you have dependencies specifically for those libraries, for example, you might have a serial communication protocol and it has some serial communication dependency. Then you would use your project, write your keywords that are using this internal library, basically wrapping around it, and then deploy this as its own Nugget package. And that's how you can basically write APIs for things that are available in C#. And that's how I always treated it. You're always writing APIs for the robot framework people to use for things that are already available to you either in C# or that you write in C#. That's my best practice, definitely, and the way to go I would recommend. Yeah.
Great. Thanks for that explanation.
There's one question. Is there a reason why all this hosting setup is not available as an extension to Host Builder bundled with the library?
Because I did not get to the part yet. It is some that's the first part that I meant in my presentation when I said I really wanted to improve the integration with ASP.NET. Is specifically this hosting part is something that I could definitely provide, and you would not have to set this up all by yourself. It's just that's the part that I haven't really gone into it yet, because it's a really usability layer that I haven't focused on. I focused on the remote library being exclusively working. I hope I demonstrated that it's for the most part working, unless I'm typing things wrong. But yeah, that's the reason for it. But it is something that I want to do. I want to really make it easy to host it with the extensions library of Microsoft.
Okay, there are, as of now, not more questions. No.
Okay, so we have seen how to create the host service. We have seen how I add the robot remote library, the main core class, to the hosting service. We have seen how to create a library class. I have not gone into depth, but we're still starting to run out of time. and how to add this library class. And lastly, starting the RobotCore is the same as we did before, and executing is also the same as we did before. So I'm just going to skip over that. I hope my explanations have been good to you, and wish you very well on your journey. And I hope I see many bugs in my repository, so I have some fixing and improvements to do, because I definitely think there are major ways I could improve.
Thank you very much, Nicholas. That was a really good one. I think it was also hard stuff for at least for people who have no clue of C#. But still, I think you explained the use case of the remote library, and so thank you very much. I hope you have a lot of fun also in the next days. Now you can totally relax, like the other speakers still have their Q&A in front of themselves, so you can enjoy the RoboCon now and yeah, relax. I wish you good luck with your new employer. May it be a bright future for you. And anything else from your side?
Thank you very much for the support in hosting and the explanation of things, and keeping your feet still enough during my craziness of not figuring out the camera.
Right.
So thank you very much for your great moderation.
Yeah, you're welcome. Also to the audience, thank you for bringing in the question. Thank you for Lydia to stay up so long. Have a nice sleep now and have fun looking the rest of the talks. I think tomorrow morning and in the maybe recording or so. So for everyone else who maybe have jumped in the middle, RoboCon is starting tomorrow morning at, I think, something 9 a.m. UTC or so, if I'm not mistaken. Just look at RoboCon.io. You will see the talks and the times in your local time zone there. We will have, again, our awesome host, Joe Colantonio from Test Guild. So, and anything else? Next up, in half an hour starting, we will have Kelby Stein about how to build up your projects bottom up. And something else? No, maybe anyone who's interested already in this evening, I think there will be some people meeting in Gathertown at the Beer. So just take a shuttle and fly to the ground and search the bar there. I think there will be some warm-up evening for tomorrow. And otherwise, see you in the next stream or see you tomorrow in Gathertown. So bye-bye and have a nice time at RoboCon Online.